The next part on foundations of risk management tries to explain the various risk adjusted measures of performance. So the performance of a fund manager may be very high. The return may be 20% as compared to another fund manager's return of 8%. The question is, who has done the better job of investing your funds? Is it the 8% fund manager or is it the 20% fund manager? Looking at the absolute picture or looking at the absolute returns may give us the wrong picture. So you must see the returns in the context of the risk that the fund managers have taken. So various measures of risk adjusted performance exist, and we'll study more in FRM part 2. The three standard measures include the trainer ratio, that is the return on the portfolio minus the risk-free rate upon beta. The trainer measure thinks of risk as beta, so beta is only systematic risk. The Sharpe measure thinks of risk as standard deviation or variance, that is the square root of variance. Standard deviation is total risk, that is it is beta or systematic risk plus unsystematic risk or idiosyncratic risk. The Jensen's measure or the Jensen's alpha gives us the same ranking as the trainer measure and also uses the definition of risk as beta. So the Jensen's alpha is the return that the portfolio has generated over and above the CAPM required return. So if so much is the CAPM required return and your portfolio has given something more, then you have given a higher return as compared to the or as what was justified by the risk of that security. So the additional return can be attributable to your fund management skills or your market timing skills or your stock selection skills. So all these three measures may give different rankings at times. So a stock that has high unsystematic risk may have a low Sharpe ratio but a high trainer ratio. So please note that amongst themselves the ratios cannot be compared. The Sharpe ratio of one portfolio must be compared to the Sharpe ratio of another portfolio. Similarly, the trainer ratio of one portfolio must be compared with the trainer ratio of another portfolio for us to make any sense. Let's do an example and understand. For a portfolio of 10 stocks, we may find via fundamental analysis estimates that the portfolio's expected return is 14% with a standard deviation of 25%. The beta of the portfolio is 1.1. The expected return of the market is 12.5% with a standard deviation of 20.2%. The risk-free rate is 2.6%. Calculate the trainer, Sharpe and Jensen measures. So the trainer will be the expected return that is given to be 14% minus the risk-free rate that is 2.6% divided by the beta that is 1.1. The Sharpe ratio similarly will be the expected return minus the risk-free rate upon the standard deviation which is given to be 25%. The Jensen's alpha will be the expected return minus the CAPM required return, which will be the risk-free rate plus beta times RM minus RF. Return on the market is 12.5 minus the risk-free rate is 2.6. So alpha comes out to be 0.5%. Sharpe ratio comes out to be 4.56. and the trainer ratio comes out to be 10.36. You can verify. You know the Sharpe ratio will come out to be 0.456. The Jensen's alpha is 0.5%. Similarly, we can compare the corresponding measures for the market portfolio. Please note the market portfolio has a beta equal to 1, expected return is 12.5, risk rate is 2.6. The standard deviation of the market portfolio is also given to be 20.2%. So we can compute the ratios for the market just as we computed for our portfolio. So our portfolio has a higher trainer ratio than the market, but a lower Sharpe ratio than the market. So probably we have more idiosyncratic risk or stock specific risk. Jensen's measure for the market is 0, or Jensen's alpha is equal to 0. The information ratio is an important ratio or an important calculation for benchmarked funds. The active return is calculated as the return on the portfolio minus the return on the benchmark. So for the last 10 years or last 20 quarters or whatever we want to choose, we can see the return on our portfolio and we can see the return on the benchmark. 9%, return on the portfolio 8%, return on the benchmark 11%, so on and so forth. Some years the active return will be positive, some years the active return will be negative. The information ratio is defined as the active return or the average active return divided by the standard deviation of that return. So we have the active return for the last 20 periods, 3, 1, 2.5, minus 3, minus 1, 1.2, so on and so forth. We can take the mean and we can take the standard deviation of the active return. The information ratio, that standard deviation, is called active risk and is also known as the tracking error, or is called tracking error volatility. So the active risk upon the active return is the information ratio. So for any particular year, the information ratio will be the expected return on the portfolio minus the expected return on the benchmark divided by the standard deviation of the active return. Please note why division by the standard deviation is important. Because if the return has been volatile, then a high performance in any one year will be scaled down, because we know next year he may underperform because the volatility in his returns is very high. If the return has been more stable, then a positive return may be expected to continue, or a positive return has more meaning because the standard deviation in the returns historically has not been very high. So it's not a positive negative type of scenario. So very important ratio, the information ratio, is the active return, or the return over the benchmark divided by the tracking error or the standard deviation of the active return. The Sortino ratio is the last ratio that we'll study, which is similar to Sharpe ratio. However, it focuses only on downside risk. So if we only want to compare instruments with regards to their downside risk, then we can compare the Sortino ratios. So the Sortino ratio is calculated as the return on the portfolio minus the minimum acceptable return upon the square root or the mean squared deviation of the portfolio. The mean squared deviation is calculated in the same manner as the regular standard deviation. So it will be summation of xi minus x bar to the power or 2 averaged and square root. However, x bar will now become the minimum acceptable return. So whenever the return is below the minimum acceptable return, this ratio will be, or this value will be considered. If x is higher than the minimum acceptable return, then that value will be ignored. So only the losses will come in our standard deviation calculation. So the Sortino ratio focuses only on downside risk. Comparing the Sortino ratio amongst different portfolios will compare the downside risk or the expected return minus the minimum acceptable return upon the downside deviation. So other values will be ignored. So the mean squared deviation can be calculated in this manner by taking only negative values, ignoring all positive values where the return is greater than the minimum acceptable return. Over a 10-year period, a manager uses a covered call strategy to enhance the return of the index fund she manages. The record of the fund's returns is 0.095, 0.08, minus 0.022, so on and so forth. The corresponding benchmark returns record is as shown. The minimum acceptable return is 4%. Calculate the tracking error, the information ratio, and the Sortino ratio. Assume the mean squared deviation is 0.001759 or 0.1759%. So for the past many years, we are given the funds returns, so on and so forth, and we are given the benchmark returns 0.087, 0.078, minus 0.034, so on and so forth. The active return can be calculated as the return on the portfolio minus the return on the benchmark. So for the first year, it will come out to be 0.012. For the second year, it will come out to be 0.002. For the third year, it will come out to be minus will become plus. So the benchmark fell by 3.4%. However, we fell by only 2.2%. So it is again a positive 0.012, so on and so forth. So this is how we can calculate the active return. We can then take the standard deviation of these returns, that is calculate the mean, take the deviations from the mean, square them, sum them up and divide them by n minus 1, which will give us the standard deviation. The average of the active return divided by that standard deviation will be the information ratio. So to compute the tracking error, first step is to compute the differences between the portfolio and the benchmark. The differences are 0.008. Please note 0.95 minus 0.87 will be 0.008, not 0.012 as we had depicted. 0.002 as we calculated, 0.012 minus 0.014, so on and so forth. Tracking error is the standard deviation. So take the mean of these comes out to be 0.0018, and then take the standard deviation, that is 0.008 minus 0.0018 to the power 2, so on and so forth, and divided by 10 minus 1, because generally if it's a sample, then we will divide it by n minus 1. So tracking error comes out to be 0.0992 or 0.00992. So the information ratio will be 0.0018 upon 0.00992, that is 0.1815. The second part of the question asks us to calculate the Sortino ratio. So the Sortino ratio will be the mean return minus the minimum acceptable return divided by the square root of the mean squared deviation below the minimum acceptable return. So the mean of the portfolio return can be calculated by summing these values up and dividing them by 10. This will be the mean return on the portfolio minus the minimum acceptable return is 4%. So mean return on the portfolio comes out to be 5.19%, minus 4% will give us 0.0119. The square root of the mean squared deviation. So the mean squared deviation is 0.001759. So the square root of the mean squared deviation will come out to be 0.0419, or the Sortino ratio will come out to be 0.0019 divided by 0.0419, that is 0.2840. Again, the information ratio must be compared with another information ratio. The Sortino ratio must be compared with another Sortino ratio in order to make a judgment and to compare the performances.